Whitaker. They worked together at Microsoft, at Google, sorry. James also worked at Microsoft, so they worked together. And yeah, he had a company that was trying to build the next generation of testing tools using AI, which was pretty awesome. And I learned a lot there. 3 years I spent as SOFTECasia's chief scientist and SVP of ML engineering. So I've also been in testing and software engineering role, and then kind of part of data scientist and ML engineering, and unsupervised machine learning, right? All right. Cool. And I talked about cluster. All right, then my favorite one, right? This is all for all the gamers out there. There's the idea of reinforcement learning. And so this is learning by trial and error. So in a way, you have some information available to you, but you don't have the full scope of information. What you're doing is generating the data that you need to determine how to make predictions. So what does this mean? True predictions. And then there's your false predictions, right? Where you have false positives and false negatives. So where it said yes and it should have been no, and where it said no and it should have been yes, right? So you have these, typically though, there's a branch of artificial intelligence focused specifically on natural language processing. Now the full answer is that there's a couple different technologies that could come together for the chatbot. But NLP is typically one. Deep learning, which we kind of talked about, machine learning and then deep learning, is typically where for these newer models, right, these generative pre-trained transformers or the transformer implementation are using a deep learning model as being trained in a particular way. And we could talk about the transformer architecture, but that gets kind of technical. But the whole idea is that to handle these NLP tasks, you've trained this deep learning model, typically using supervised machine learning, right? So you kind of already have like how GPT and stuff is all trained. There's a corpus of data from the internet, right, which is a lot, right? And it is trained on that data, right? The transformer architecture, and these were always trained in this manner even before we had this generative pre-trained transformer. But the transformer model allowed it to become much more efficient. Because as you can start to think, if I'm training like on textual data, I want to teach the machine how to speak or how to respond. There's a lot of nuances with that, right? And back in the earlier days of NLP, we would use things like recurrent neural networks and different architectures, but they had to be trained sequentially. With this new transformer architecture, it allows things to be trained in parallel, and that's where we've got in like a lot of advances in chatbot technology. So supervised learning for training the initial system. However, reinforcement learning is also a very key part of this. Reinforcement learning is because typically if you want your chatbot to be improved, you will want to have reinforcement learning from human feedback. So it means that as you talk to the chatbot and it really messes up, you can say, well, you see this if you use any kind of ChatGPT, you can actually click a thumbs up or thumbs down. That is your reinforcement learning mechanism. You're saying this was a good answer or this was a bad answer. In the context of what you saw visually here, like clicking down is like making it hit a wall, right? You just hit a wall. This was not good. I don't want you to do this behavior. Clicking a thumbs up is like saying jump over the wall and keep moving. So you're providing feedback in this way, and that's an element of reinforcement learning that's also being employed. So building like a chatbot is not one kind of trivial thing, and it might use, and it also could use unsupervised machine learning depending on your problem domain. But typically you'll see, supervised learning and reinforcement learning at play with the chatbot technology. That continues to go through these episodes. But as you can see, this can take quite a long time and can be very resource intensive. But if you think about how self-driving cars are trained, this is exactly how they're trained. So typically these systems really suck in the beginning. They don't perform well. So over time though, they get better and better to the point where like you step back and you're like, wow, right? And these are all problems that are very hard, right, typically, to do in a procedural manner. So remember we talked about explicitly programming? If you had to try to explicitly write a program to drive a car, really hard. Where would you put the if-then statements all over, right? It wouldn't even work for you. but through machine learning we've been able to succeed at solving some of these harder problems. Alright, any questions, comments, queries? So now we know what AI is, right? This large, broad field of computer science. It deals with how we reason, how we learn, kind of simulating human intelligence. Machine learning provides the programming model, right? So this is how we try to avoid explicitly programming these machines. We want them to act without this explicit programming. And we looked at supervised learning, unsupervised learning, and reinforcement learning. Any questions? That's a lot already, right? Yes. Example of how unsupervised learning is implemented? Yeah, sure. So, the most common form of unsupervised machine learning is something called clustering. The most popular algorithm within that is something called k-means clustering. And k-means clustering says, I need some value k. You can have k equals to 3, right? And I think there's a point here where I do talk about that. So there's some slides that you can refer to after I just give you a general things. But k equals to 3 says I want k centroid. So just think of 3 dots in space, right? These are where I'm going to form my clusters. So these are 3 points in space, and I'm saying whenever I get a new data point, I need to assign them to the closest cluster, right? So I'm going to go through and I'm going to say hey, for this data point, if I'm clustering this data together, where does it fit, right? And I will assign it, and I'll keep going through that process of assigning. Now how it assigns it is just kind of how the algorithm works, and it depends on the features that you're caring about for your data set. But it goes through and it starts to just divide it into those 3. Now, is it perfect? Will it maybe have something that might be, so you can start thinking about the distance away from the cluster as kind of like the, sort of the, not efficiency, but the accuracy of, how these things are assigned. So there's a lot of analysis that you can do there. How you do it in practice. Like for example, in the testing world, I worked on a project where we were using AI to explore an application and do accessibility testing. And of course with accessibility issues, if you think about it, we're using blocks, we're crawling to a web page, and then we're looking for different classes of issues. Let's say that we find on one page a set of accessibility issues. Maybe there's not certain labels that should be on elements on this web page. When we find an issue like that, right, what we want to do is to group these issues together so that someone doesn't have to look through a report and we're missing these labels from access alt text on all these elements. It will use those things as features. It will use the alt text and whatever it needs to look at, and then assign it to different clusters and then use that as the grouping. So practically, and again, you can use this for anything. I'm just giving an example of accessibility testing. But you would just throw all of the errors at the machine and get it to cluster them all together, and then we did this, and then it neatly groups everything, and then now that someone is looking through all the issues, they have just very few nodes. When they click it, they see all the nodes that were assigned, and that was really done through machine learning and k-means clustering, right? There's other algorithms like k-methods clustering, so there's different ways to do this, but all the principle is the same. You want to say what features you care about, and then you just want to throw the data at it, and then it just seemingly does the magic. Right? But there is a training process behind it. We'll talk about that. All right, very good question. Any other questions? Yes.
Like a chatbot, it's like any banking website, so you can see that at the top right corner there's a chatbot there. So this kind of.
All right, so that's a very long version of me. Outside of that, as I said, I'm from Barbados. I live in South Florida, so you saw yesterday that I live in beautiful places. I'm from very beautiful places, and I do love to travel. And I do think that this country, this place, was one of my most memorable places to come to visit. Primarily for the food. I don't know if you all realize how wonderful the situation here is if you like food. And I love food, right? So this is, and also it was very surprising to see, me very, very well. I don't think I have anything else. Maybe one or two secrets, but now it's time for me to kind of get to know you, right? And I know people here don't like to talk, but we're going to talk because we're going to be spending like the next 3.5 up to 4 hours together, so we need to understand each other. It's not that many people, so we'll make this very quick, even if you're very shy. I'm going to go around, and y'all are going to tell me just 3 things. Right? This is all you're going to tell me, 3 things. I want to answer you just in time for the fun game that we're having. You know? So, all right, you're going to tell me just your name, you know, the company that you work for, and your role, and then you're going to tell me why you signed up for this course. Like, what do you hope to learn, or what was your motivation for signing up, right? All right, so I know the people in the back are the most allergic to teachers, so we'll start from the back. All right, right here. Go ahead.
Hello, good morning. My name is Amir from SIF. Current role is here as engineer. What attracts me to join this course was currently the company label we are starting to do AI machine learning program benefits us what can help us to stay on the business concept point of view and from our side to look into how it can help our business.
Okay. Cool.
Let's align with the company direction.
Nice. Thank you. Nice.
Hi, my name is Daniel, also from SWIFT, also work as engineer. Same reason as machine learning because it's the company's direct.
Okay. Cool. All right, we'll go here.
Hi, I'm Grace from Archie Denver. I'm the head of testing. So the reason why I signed this course is because my company currently we have some of the applications which is AI things. So people are asking me what are the guidelines that they want to do with this thing. So I as the one that doing the test governance, I will set up the process and tell them that what exactly they need to follow. So this one know how do I carve out this entire guideline.
Very good. Awesome. Thank you.
Hi, my name is Steve. I'm also from RP.
So we just like sit in pairs of our thing, right? So I should make everyone move around. All right, go ahead.
Same reason, also would like to know more about AI.
Okay. Awesome. Right here, sir.
Hi, my name is Stanley. I'm the Director of Quality Engineering. I work for Kinesil. It's a US-based company. I'm the IPT media brand. The reason why I'm here because we are currently evaluating AI-powered test automation. So, yeah, we'll see. We have the success criteria, all those stuff, so we evaluated that. So I just want to learn more from Tariq, what else can, all angles covered.
Awesome. Yes.
Hi, my name is Umar Baby. I'm from BAE Systems.
You're from his company too?
No.
Good. Thank you.
How about this is actually my ex-coworker.
He's your ex-coworker? I guess everyone here has friends, even though like we all came here from different places. Everyone just find a friend.
Right. I'm from BAE Systems. It's a UK-based company.
Okay.
And then the reason I joined this course is actually we already implemented with the AI-based testing. So I would like to know more. We want to be as part of the team. Actually, we want to enhance with this technology how to be used to towards the testing part. Second is actually we want to go towards the software engineering, how the process has been set up, so we will need the guidance for the rest of the team. Thank you.
All right, right here.
Hi everyone, my name is Becky from BAS. So my current role is creativity. The reason why I'm doing this is because I'm wondering how is AI applied in software testing.
Thank you. All right.
Hi everyone, my name is Kat. I work with Uma. So I work together in BAE Systems. The reason why I'm here because I really want to know what's the pros and cons for AI and machine learning. Because I'm very, very curious about it.
All right. Awesome. Right here.
Hi, I'm Moni from Family Medicine. So I'm currently on a software QE. The reason why I'm doing this session set of the data analytical and security, because I want to do more on the AI in terms of testing.
Yeah.
Hi, my name is Hasyati. I'm from VNet. Currently I'm doing testing for set magnetic transaction. I joined AI what I know is ChatGPT. Help me to send email to my boss. And then I want to know more what AI can do.
Very good. Awesome. Thank you. All right, over here.
I am Alex, currently in the class of operations. I am in business.
All of these guys? And those? So I need to go to the Philippines is what you're saying. Okay, that's fine.
I'm a manual texter, and I'm very curious about how it can integrate with the testing and what are the risks of using it.
I am also from Renewable Energy. The reason why I'm very interested in more about it.
All right, you're here.
Hi everyone, I'm Rachel and I'm a testing and I'm from the same company, Day&Go. And my reason for being here is we're actually improving our QA testing by applying AI. So we want to learn more about it. So that's all.
So let me just say something. This company that y'all work for is amazing, right? Because normally people will just send one or two people. And then say, okay, sorry, I'm a business leader, right? So you normally say, well, I'll send the two of you, and then y'all come back and share what you learned and everything. So the fact that they were like, no, all of y'all can come, and then it's actually very good.
Actually, we are here because we want.
All right, let's get started. I guess people will hear us out and run our walk. I don't know exactly when, one thing we check on is when the break times are. So I'm assuming that there's breaks in between this 4-hour period. But I'll find out. In any case, I will take a break when I feel like it is necessary. But also feel free to, I know how everything is here at Hunts Right Proper, but if you need to break for whatever reason, do not worry about exiting, using the restroom, etc., or if you have to take a call, whatever it is. I'm not a very formal person. Come on in. I guess you are still, okay. All right. So, let's get started. So I think y'all in the right place, right? Quality engineering, introduction for AI and machine learning. The first thing that we normally have to do is level set on expectations, so we'll do that. But first, let me just introduce myself. I'm Tariq. I have kind of spent my career in software testing, or quality engineering, or you decided to identify it. But I was very fortunate to start off at Florida Tech. Florida Tech is University in Melbourne, Florida. We were very fortunate when I was going to school there that we had two very great minds in software testing that were teachers there, Dr. James Whitaker and Dr. Ken Kaner. So software testing was actually like one of the only electives that you could take twice and get credit for both courses, even though it was the same elective. If you took it with James or if you took it with Ken, it was credited to you because their styles were very, very different. So that's where I got introduced to software testing in college during my bachelor's degree, which is not something that normally happens. Most people get into testing sometimes as much as being already in a job and someone says, hey, we need someone to do testing. Do you want to do it? Right? So I had a very good formal education in software testing, and I decided to pursue a PhD in computer science from Florida International University after I finished at Florida Tech, and focus my dissertation on software testing. particular, I was focused on autonomic computing, which at that time, Microsoft and IBM and all these tech giants were trying to focus on what would the next generation of systems look like, right? It's ironic because we're at this conference and the theme is next generation, right? So we're always looking at the next generation, and back then, IBM and Microsoft, HP had initiatives around what is either called autonomic computing or the dynamic systems initiative. They had different names, adaptive computing. So we had all these different names for the same thing, which is, can we build systems that actually are able to anticipate the user's needs and adapt to changing environmental conditions so they can self-configure, self-heal, self-protect. Things that sound very familiar nowadays, right? And back then, there wasn't a lot of the advances in AI that we have now with deep learning and so on and so forth. So when I was doing my dissertation, a lot of it was focused on really kind of dreaming up stuff and finding technology that could be used to try to implement these ideas, but thinking about testing up front, which no one was doing. They were all talking about all these self-healing and self-this, and no one was thinking we need to do self-testing if we're going to do all this self-stuff, right? So that was what my dissertation focused on. It focused on introducing a new inherent self-testing characteristic into these systems. And the reason that I say that is not to give you a big history on my dissertation, but right now, like, we're living in an era where artificial intelligence is implementing a lot of these dynamically adaptive features that people are dreaming of, right? AI is able to learn at runtime, right? Is able to help generate new things that, you know, you can't anticipate and test offline. So testing needs to move into the runtime. So, you know, what was, you know, no one reads your dissertation except maybe yourself, your advisor, and hopefully someone else at least looks at the cover, maybe your mother. But normally people don't read that stuff. But fortunately for me, like, I think what I was working on was ahead of its time. So I think now I think we need to actually read my dissertation. So that's the first homework assignment. No, just kidding. Anyway, I would start off my career. Actually, while I was in university, I got an IBM fellowship to do international research as part of the grant that we had. So I spent 3 months in Beijing, China, working with IBM there. That was pretty cool. IBM's China Research Lab. That was a great experience. But I also got an offer from IBM after I finished there to work at their IBM TJ Watson facility in Hawthorne, New York. At that time there was a big recession and there was a lot going on and no one was getting job offers, and I had 2 job offers. One was from IBM and the other one was from North Dakota State University in Fargo, North Dakota. And I decided to go to Fargo, North Dakota. Y'all may not be familiar with Fargo, but there's a movie. If you watch it, one thing you'll see in the movie is a lot of snow. And that's what people know Fargo for, is how cold it is. And they're not lying. It is very cold. So, ironically, you're around -40 degrees, right? And that doesn't matter, Fahrenheit or Celsius, that's the same number. So, just very, very cold is how that equates. And then I would have ended up staying there. I'm originally from Barbados, so I'm not very good with cold weather long term. But it served a purpose. There I worked a lot with Microsoft. There was a Great Plains campus near to where I was working, NDSU. And a lot of my students were from Microsoft, and I would collaborate and work.
The thought. So yeah, so how do we, like, our conventional testing, like we have the expected result and the actual result. So how do we do a comparison like this?
So we will get there. Let me continue to go through like how these systems are built, so you can understand how they're trained. But what you're talking about, especially in the context of chatbots, right, is you're talking about the non-deterministic aspect of this technology. And that requires a very specific kind of outlook on testing that we will cover. But it's very specific to the dynamic nature of it, of generative AI specifically. So I don't want to, again, I'm trying to make sure that we set a very broad foundation, and then we can hone in on generative AI Because right now, like, everyone feels like generative AI equals generative AI, and that's not necessarily the case, right? So we'll go through and see how we actually train these systems, and then we can talk about, once we move into kind of the more dynamic and runtime aspects, I will make sure to address how to test the non-deterministic nature of these elements. And it's also note that this is a very new area for people. So actually some of the things that I'll show you are things that only I have seen. Myself is the only person that is writing about them in the testing community. People are mentioning them, but no one has put forward like very specific test strategies. Actually, like hopefully, before I leave Malaysia, or at least before I leave Europe, because I go from here to Europe, I'll post an article specifically on testing techniques for the dynamic nature of generative AI. Because I've been working on some of those things. All right. So, just to kind of wrap this part up, agent takes actions in the environment, moves to a new state, right? We saw that kind of like visually here. And just understand that like, this whole idea is that there's all these different types of agents. You can have a very simple reflex agent, so if then, kind of thing. So we have a good one in here is this air condition that was freezing us yesterday in the room, right? In a normal situation, you would set a temperature to your AC, and there's a sensor that monitors the temperature, and when it hits that temperature, the HVAC system turns off or turns on depending, so that you can keep or maintain that rule. So that's a very simple reflex. If this happens, then do this. Doesn't seem to be working in this case because it's just trying to freeze us, but that works. Model-based agents build models all the time. We as human beings build models, right? If we turn out the lights in this room right now, all of you would know how to navigate to the door because we've already built a mental model. Earlier when we were here in the room and I was going around and we were all introducing each other, I built a mental model. I noticed that that seat was empty. And then I noticed when it changed, when the seat became full, right? So subconsciously we build these models, and all you can do here is have the agent build models so that the agent can know how to deal with change or how to deal with uncertainty. And that's the same principle there. Goal-based, right? You just set goals, we just talked about that. Utility is similar to setting a goal, except it's thinking about the local satisfaction, right? Thinking about my next action, right? And what makes me happiest, right? So, for example, we are in here right now, and maybe the next action that will make you happiest is to know that, hey, there's treats outside, so we need to get up and go get treats. And that will be the local satisfaction. The long-term goal of staying fit might not be part of that equation, but the local satisfaction will be maximized, right? So there's a difference between the goal and utility, right? And then all these are learning agents. So the cool thing is that I've seen there's a lot of different models, everything from neural networks, which is what is most commonly talked about, decision trees, Bayesian networks. We talked a little bit about k-means clustering and k-medoids and how we assign these centroids to cluster. And then Q-learning is a very popular model-free reinforcement learning algorithm. So these are all different types of models that are used for machine learning. I've been in projects that have used all these different types of models to help make software testing better. So you normally are choosing a model to help solve a problem. We'll talk about making sure that you put the problem first in these cases. But these are all valid to understand that there's a lot of different ways that you can implement machine learning systems. It's not all about neural networks. For example, neural networks are not very explainable. It's hard to know what's happening in a neural network because they're so big. Usually, right? However, a decision tree, which is very similar to a decision table, it's very easy to explain how the machine came to an answer because it's following the nodes of how it made the decisions and what were the values there, right? So, something like that. All right, so here's where we're going to start to shift into. Let me see what we're doing in time. So that's 15. One thing that I, again, still don't know, which maybe once I see, is does anyone know when break happens or how breaks happen? What, 10:30? All right, cool. This is good. See, I knew y'all would know. next question will be how long is the break supposed to be? But I know that there will be a bell anyway, so like I'll know when we're supposed to come back. All right, so let's try to get to this exercise here, so that we can do this before we go on break. I want you all to get experience just playing around with training a neural network, which is really fun. But first, let's just talk about how neural networks work. So the first thing to understand is that the model that we're going to start with is a very popular model, and it's based very loosely on how our human brain works, right? And I say very, very loosely, right? So human brain, very complex thing, has about 15 to 33 billion neurons firing at about 200 miles per hour. You can do the conversion to kilometers per hour if you so desire. I have no idea. But a lot of kilometers per hour, that's what I would say. And they're actually very complicated, but if we boil down like an artificial neuron, and this is how, obviously biological neurons work, they accept input, right? So there's a number of input axons that feed into this neuron. And then there's this activation function, right? So you're saying input, processing, and activation, and then that produces output. It's a very simple computational node, right? So how does this really factor into machine learning and how something is trained? The first thing to note is that even a very simple version of this set of neurons where you have input layer, hidden layer, right, which is going to be your neurons that will fire in between, and your output layer, is very useful in applying to general problems, right? You can apply it to almost any problem. Everything from like what, identifying cats in a video, to doing credit card fraud, to doing facial recognition. This is very powerful technology, right? And so we're going to see, first of all, how this works in practice when trying to train our own neural network. And then we're going to come back and then pick apart like, how it actually works, right? So I'll talk about this in a minute. The first thing I want you to do is so I want you to navigate to this website. Let me just get here. I need this machine, if I ask it a question, I need it to kind of only return to me valid results that are valuable. It would be better for it to say nothing or return nothing than for it to return something that is inaccurate. Because it's life or death here. So I need the system to be very precise. I might not care that it grabs the whole set of every possible answer, but whatever answer it brings me, it better be right. Alright? I need it to be very, very precise. Every answer I can rely on. Otherwise, no answer is better than an answer. With me so far? Cool. Here's another situation. I heard y'all have like some shopping season, is that true? Like sales season? Is this a thing? Like my wife hasn't been here, thankfully. But if she finds out that there's something called the shopping season, she will definitely be here, right? And the only reason she hasn't been here, we were having a baby the first time that we were coming here, and I had to come on myself because she's very, very pregnant. But normally when I'm at these kinds of events, my wife and children are with me. Our kids are homeschooled, so they travel a lot with us. This is so they can experience the world. But let's say I'm here and my wife is here, and if she was here, I can guarantee you she wouldn't be here, she would be out there shopping, right? And I might get a call on my cellular phone saying, hey, we just got a charge for like, $2,000, and it's coming from like such and such a store, right? Louis Vuitton, right? and we think this is fraud, Mr. King, right? And I'm like, no, it's not fraud. My wife and daughters are actually out shopping, and there's probably going to be a couple more of these charges, and sorry that you wasted your time, but this is not fraud. Now, me personally, whether they call me one time or 10,000 times, I don't mind, right? Because I want to make sure that if there is any fraud, that is important for them to catch. So I'm not concerned with how many times they get a wrong answer. I'll let you brainstorm. They can get the answer wrong all day long, I'm fine, right? Because I'm trying to optimize recall. So in other words, catch more of the things that might be possible. And it doesn't matter if you get them wrong, because I want that one time that it is fraud, that you capture it. So your net can be a lot wider here, and your opportunity for error doesn't matter as much. So precision versus recall. And you can see how there's a trade-off. Because the wider my net goes, the larger the probability that I get something wrong. So precision and recall are kind of like in this kind of tension. But it's important, and there's a very easy way to calculate precision and recall. Precision is just the true positives over the true positives plus false positives. Recall is the true positives over the true positives plus false negatives. Right? What is important is that you conceptually grasp these things, because most of the formulas and actually most of these things are one line of Python to calculate these things. So it's more important that conceptually you understand the difference and what is important and how there is a trade-off. And then there's something called the F measure or F score, which is really the harmonic mean of these two things. So an F score trending towards 1 is perfect precision and perfect recall. Alright? So that's the best of both worlds. Alright, any questions, comments, experience? You could fact check me. I know how it goes. I know the things. Alright, so we kind of got through like how these systems are built, how they're evaluated. And I want to show you now, like again, part of it was to get to this point. There's just one or two more extra points that I want to touch on before we kind of shift gears. One of them is the fact that these are not easy problems usually that machines have to solve. For example, some humans get confused with like big cats, right? I get confused sometimes, but hopefully I never meet a big cat. I need to know which one it is, right? Because that is not really myself. But either way, there's a couple interesting aspects of this. Because as you train a machine learning model to do classification, for example, you could get these false positives or false negatives, right? Or true positives or true negatives. And as you deal with this, you understand that there's different variables or values behind the scenes that can be tweaked, like thresholds. So for example, let's say that I'm getting a lot of false positives on identifying tigers. So whatever I'm doing, the machine is getting confused and is thinking that this thing is a tiger and it's not. So what I might want to do in that case, like let's say it's coming back with a 40% confidence that it's a tiger, I might want to raise that threshold. I might want to say you need to be at 60% before you call this thing a tiger. So there's some variables behind the scenes that you normally can tweak or look at in terms of precision and recall to then improve your overall quality of your predictions, right? Similarly with crocodiles versus alligators or something like that. But the point here is that there's definitely a lot of different elements that we'll see in a second. There's the precision recall curve, which is you can just look at the area underneath this curve. Again, complete area here is perfect precision and perfect recall. There's something called the receiver operating characteristic curve. And in that, you're looking at your true positive rate on one side and your false positive rate. And this is where you can look at certain thresholds to see if you need to tweak something to improve your overall precision or recall, right? These metrics, right, and having to influence, how can we go like this and improve the overall quality of the system? If the system is predicting something and it's getting it wrong. Well, how do you fix it? Well, this is how you start to fix it. So by mapping like the external user experience with what the ML engineers are doing is how you bridge the gap between the system, overall system quality, right? All right. That was a lot. It's very interesting. It's only 11:45, right? And this is, y'all gonna regret doing this, or are they be very happy with it? Either way, like, your brain is gonna, right? But we're gonna make sure we break through something fun. So there's diagnostic tools. These are two elements of the diagnostic tools that you can actually visualize. What I want to show you here, because all of my courses, I like to make sure that this is practical, and this is not just something that is theoretical. And so I spent a good portion of my life. So there's another URL here, tinyurl.com/testingml. I can probably try to do that first again before you do. This will launch what is called Jupyter Notebook. Anyone familiar with Jupyter Notebooks? Heard of it before? Seen it? No? No one? Wow, this is great. It means that I could say anything and I will be right. But no, I wouldn't do that, right? So this will load, hopefully, in a second. And I'll be able to navigate around it. But what it was is that I took actually a great portion of my life while I was chief scientist at SOFTECAsia to build this up. Because as I was leading the ML engineering team that was building our platform, and I'll talk to you about what that was all about, I realized that we needed content that people could use to help to digest these concepts. So I just drilled into the notebooks folder. You can feel free to follow along, if not just pay attention. The URL is there and you can always navigate through these things. And a lot of it is self-explanatory once you see how it works. So you'll see that I have a series of notebooks here, 1 through 8. It's a lot of content. The first notebook, which just has instructions for the teachable machine, we actually did this exercise in a way. This exercise just tells you to try the teachable machine, and then you can get hands-on with the machine. There's a little bit of an extra exercise that you didn't do based on time, which is coming up with test strategy. I kind of hinted to you to think about testing as you were doing this, and of course, it's natural. You're going to train the model and then see if it works. It's the lens itself there. But if you want to get deeper on that, there's definitely some more guidance there on doing that exercise, right? The one we're going to focus on, and I'm going to show you how these things work, is this second one, which is a classifier performance or model performance notebook. So the Jupyter notebooks are cool because these are all heavily annotated. So no matter how much I've talked to you about, there's more information here than I would have talked about. And so you can really use it for self-paced learning. So you have this model performance classification. It tells you here the different types of classifiers that you can build. You can build a binary classifier. This is like our yes, no that we were looking at. Or you can have a multi-classification problem. You can say this is an apple, this is an orange, or this is a grapefruit, right? So it talks about that. It shows you some different types of examples of different classification problems. And then it talks about things that we mentioned before. Accuracy, gives you the formula there. Error, the confusion matrix, which you all understand already, right? And then the cool thing that is really awesome about Jupyter Notebooks is that it lets you have access to an environment without all of the work of having to set it up. So normally in a training like this, if I needed you to do an exercise using Python, we would probably spend like most of the time getting you to install Python on your machine. And that is painful, right? Jupyter Notebooks let you have access to this web interface that actually has a Python environment running behind the scenes and lets you edit the code from this interface, right? So for example, this is one of the first hands-on exercises that are part of this whole thing, where I just get first people to see how things look and how they're structured. So how this works is that you can click on a cell, right? It's editable, so I can check here for them. But if I click on the play button here, it actually executes that line of code. Right? So I just imported what is the scikit-learn metrics library. Here I'm not going to train any models. What I'm just doing is defining two arrays, one that has actual values and predicted values. So all I'm saying is that let's pretend that I did training, and each one of these things represents what the results would have looked like in that confusion matrix, right? So here I would have had actual value that I was expecting was 0, and it came back with 1, similar thing here. So these things are some level of errors, right? Here it said 0 and it's supposed to be 0, wherever it said 1. So I'm just simulating like if I trained a model that was supposed to come out with yes or no's, and what that results matrix would look like, right? So I defined that, and I'm just doing that for the purpose of showing how these libraries in Python can be used to do things like calculate accuracy and confusion matrix, right? So here I just literally have one line of code that takes those results from that, and it produces the accuracy score, and I have another that just lets me print out the confusion matrix, right? So I can see where it was confused and where it was not confused, okay? All right. And then I continue to kind of talk about getting a little bit deeper on some of these concepts. So we just walked through this. We talked about true positives and true negatives, false positives, false negatives. So these are just notes based on everything that we talked about. This is why if you were taking notes, I probably should have mentioned this earlier, you probably don't need to take notes in this class unless I say something really profound, which normally never happens, right? But I explained the concepts of precision or recall, the F measure, again, we have these in the slides. And then this is more of a deeper dive into precision and recall, right? So here, I kind of start to put the code blocks a little bit more together. I can execute this, and I can see like this one basically just sets up the model results, and then allows me to calculate precision, recall, and F score, right? So it prints this up here, right? I can also use a function in scikit-learn as well, metrics, to print an entire classification report. So with one line, I can present this whole classification report that calculates precision, recall, F score, accuracy, etc. Just with one line of Python, right? So, and these are very popular. So this is what the machine learning engineers are going to be using, our data scientists. Some of them live in these Jupyter notebooks doing this stuff day in, day out. So it's important for you to get familiar with it if you're going to step into that role. And then what I have here is just an exercise, right? So the exercise here is to take this problem. I modeled the problem here of an email classification system where it's going to detect if the email is spam or not spam, which is a very popular problem that's solved by machine learning. And then all I do is give you the actual values and the predictions, and all it's telling you is to define, your prediction arrays, right? So you're basically looking at the code above and putting together the whole program, and then you put your solution here, right? So we're not going to do that because I want to make sure that we get to a bunch of other things, and this is something, quite frankly, that is fun for you to actually spend your time and do it with time. But I will show you that as part of this, if you go back to the top level here, there's actually solutions in here. And so any of the notebooks that has exercises like this, I have actually a solution notebook that has a possible solution. So don't cheat, doesn't have to be cheat, right? But just know you can work on the exercise, and then you can go and look at the answer, which is like the definition of self-paced learning. All right? Any questions or comments? And again, this is like, I don't know how many, so I've taught this class many times, right? And I know for sure when I've taught it already, a lot of the data scientists and a lot of engineers and folks really take advantage of it. Because they're learning testing skills later on. I'm sure that there have been some testers, folks that I've taught this to, that have kind of picked it up. But I know how much activity happens on the Jupyter notebooks, not because I'm monitoring it, but because like this is a free instance of the Jupyter infrastructure. So it gets capped at 100 people, simultaneous users, right? So if there were as many people that I've taught actually using it frequently, I would run into much more issues when I try to actually host it, right? But just trust me that these things are important skills for the future of test engineering.